All right. All right, looks like everybody is joined so far. So good morning or good afternoon. My name is Paul Kruger. I'm the CEO of our Center for Alumni Relations and Advancement. I'm filling in today for our new Director of Alumni Relations, Shelly Gernager, who is traveling with her daughter, who's going to be a freshman here at Mines. They're over in Paris, in that part of the world for the last couple of weeks. So glad you're with us today. We are 2 weeks away from when our students will move back to campus, and the classes start on the 22nd. So the life of campus will soon be returning. It's also the start of the Sturgis Bike Rally. So we actually are utilizing at least a couple of our residence halls to allow guests for the bike rally to stay on campus. So every morning during the day, I've heard about a dozen or 15 bikes take off from near our building here at the Pearson Alumni Center. So glad you're here today for our department update. It's art and engineering is the feature today. And this will be recorded and uploaded to our YouTube channel. So if you want to watch it again or send it along to a classmate or friend, please do so. And we'd encourage you today to jump into the chat function, which is at the bottom of your screen, and just tell us who you are and your graduation year and major if you'd like. And then also there will be time for question and answer. So there's a question and answer box at the bottom as well if you want to put your questions in there for our presenters. So glad you're here. And at the end, we'll just talk a little bit about upcoming events and a couple of reminders. So today's presenters are Dr. Katrina Donovan. She's a lecturer in our Materials and Metallurgical Engineering Department. Prior to joining the faculty at Mines, she worked at HP Incorporated in the 3D printing division. She has her undergraduate degree from South Dakota Mines, her master's from San Jose State University, and her PhD from Oregon State, and she's been on faculty since 2019. Our other presenter is Dr. Mike West. He's our department head and associate professor of materials and metallurgical engineering. He's been at South Dakota Mines since 2006. His undergraduate degree is from Arizona State. His master's is from Texas A&M. And his PhD is from the University of Tennessee. So Drs. Donovan and Drs. West, we appreciate your time today. We know you are busy with other things going on besides just preparing for the school year. So thanks for being here, and I'll turn the program over to the two of you. So thank you.
Thank you.
Excellent. Thank you, Paul. Excellent. Thank you so many for attending here. You know, and I told Dr. Donovan that she should switch this slide to put her name before mine because as you're going to see, she's really helping to lead these efforts. You know, what we wanted to talk to you about is just some of the exciting new initiatives in the department. And you can see this is related to this concept we're calling art in engineering, art plus engineering. And so that's integrating art into our metallurgical curriculum. And we're really excited to tell you about this initiative. We want to tell you a little about the history of how this came about. I know some of you on this on the teleconference here know a little about the history, but thought we'd talk to you a little bit about the history of where we've come from and then what we have going on right now and maybe what we have planned with this new effort. So excellent. So we'll go to the next slide. Just to remind some of you, I saw that there's a real diverse group of alumni on this teleconference, and so just to kind of give you a reminder of our program and what we focus on. You know, we have one of the few metallurgical programs in the US, and we really value that uniqueness and especially our tie to industry. You know, we teach in several areas. There you can see kind of a flow chart of what we teach. But you know, we start with the raw materials, what we call critical minerals in a lot of cases. We process those materials to make something out of them. So we're the ones that produce metals that are used in a lot of different applications. We also process those materials and then we make sure they can perform. So we're the ones that do the testing and performance. And then something that's becoming more and more critical, as you all know, we're also the ones that recycle those materials, so kind of feed it back into the front end. One of our biggest industry partners is Nucor Steel. As an example, they're the biggest steel producer in North America, but they're also the biggest recycler in North America. And so that is becoming even more and more important. Anyway, so we're gonna kind of jump right into kind of a fun video, I think, here, and then we'll talk about it.
The South Dakota Mines team set out to make our own version of an 1860s cavalry saber using 1095 steel, which is the modern equivalent. Historical research found that some period swords were tempered in unique ways using molten lead. This inspired our team to do an isothermal ostempering process to get a bainite microstructure. The isothermal treatment was accomplished by quenching the sword in molten lead at 340 degrees Celsius and holding for 1 hour. Proper PPE and safety standards were maintained during the making of this video. All forging was done by hand at approximately 1200 degrees Celsius. The time in the forge was minimized to reduce decarburization when possible. We started with a straight blade, then pre-bent to the opposite side of the cutting edge. During the beveling process, the blade naturally sabered the correct direction due to steel expansion. In order to maintain safety while working with molten lead, we held a fan blowing fumes out of the garage, as well as wearing masks and eye protection. Straight from austenitizing, the blade was quenched in a molten lead bath and held for an hour. The temperature was maintained with a pyrometer and frequent agitation. A wax mold with sprues and vents was dipped in a suspended ceramic slurry to create a cast form. This was fired to completely harden the mold before casting. We wanted to create our own guard and pommel by investment casting brass, inspired by historical designs. The handle was wrapped in white rayskin and brass thread. The team recreated historical floral scroll patterning above the ricasso using an acrylic paint and an improvised electro-etching technique. The handle of the sword was secured by peening the tang. A blade balance calculator program was used to measure the effectiveness of the blade design to make sure optimal balance.
Sorry about that.
No, well, excellent. I just love watching that video. It's so cool. I thought I'd give you a little background on that video. Really, it showcases, though, just a lot of the talent of our students. And so what you saw there is a culmination of something that we've been doing for several years at the School of Mines. And several years ago, we integrated blacksmithing into our metallurgical engineering curriculum. And the idea was being to use hands-on learning to enhance student understanding of the fundamentals of metals and metal processing. And we had a lot of success with students getting a better understanding. One of the outcomes of this effort was actually establishment of an international student competition. So what you saw in this video was the competition video, which our students made for the competition that was held this spring for the materials TMS, which is the Minerals, Metals, and Materials Society conference. And they've sponsored this competition for the last about 8 years. And it's kind of like Forged in Fire, except the focus is on the science behind making a blade. And the students actually took second place out of over 20 universities from all over the world. And so we, several years ago, we had this idea of integrating blacksmithing into the curriculum, and really led to a collaboration with a lot of local artists. One of these lead artists there is Mr. Jack Parks, who's a master blacksmith from the area, from Piedmont, South Dakota. And so based on a lot of these activities we started doing, the students started taking off in a lot of different directions and doing creative and artistic activities related to metals. So we had this idea, could we use this idea of focusing on, instead of focusing on the hands-on learning aspect, could we focus on the idea of integrating creativity and artistic aspects into our curriculum? So this is kind of this concept of, maybe some of you have heard of STEAM, which is arts and STEM, or integrating art into STEM. So if we can go to the next slide. So the goals of this new initiative are to, can we have more creative and innovative students? Can we learn things about entrepreneurship and creating innovative products, or even designs that consider both function and form? We also wanted to use some of these activities to increase teamwork in our program and collegiality, with the end goal being to increase the quality of our graduates and make our graduates more well-rounded and desirable for industry. So we we pitched this idea to the National Science Foundation through this program they have called the IUSE program, IUSE, which stands for Improved Understanding in STEM Education. And the idea was to modify, sort of further modify our labs with co-curricular activities related to ceramic materials and glass materials to just enhance this idea of creativity involving materials. So we also proposed in this program adding both co-curricular but also new curricular components to strengthen our program in the area of ceramic materials. And these classes would cross-cut a lot of programs on our campus like geological and chemical engineering, but would also strengthen our metallurgical engineering curriculum. It turns out ceramics have a lot in common with metals, but they're also vital in metal processing and in the production of metals. This idea of integrating ceramic materials actually has a lot of relevance in metallurgical engineering. So some of the other elements of the program are to establish an artist in residence, and we've done that. We've teamed with, that role is being filled by Professor Emerita Deborah Mitchell, who taught art here at the school for many years. And also we have collaborated heavily with the new art faculty, Mr. Matthew Whitehead. He's the current art lead here on the faculty. But the idea was also to partner with local artists. And the key partner in this area is Toni Gerlach, who she operates Mind Blown Studios, which is at the Pump House in Deadwood, South Dakota. It's this amazing place where you can have a cup of coffee and watch her create art using glass materials. But she's really helped us, get off the ground and start setting up a glass blowing lab in our foundry building. She provided an anchor gift of equipment and materials and supplies to get our lab started. And another element of this program is to establish a STEAM student organization, and that was led by Dr. Donovan. And so that STEAM organization is actually now one of the largest on campus. It has a very large student population, but the idea again is creative uses of materials. And so those were some of the aspects of the program early on that we wanted to establish. So now what we're going to talk about are some of the things that we have done and are starting related to your program activities. And the first one, so we're in the first year of this project, and one of the first co-curricular activities that we're integrating into the program right now is metalworking. And we've done a lot of this metalworking in the past, and the focus has been on kind of the hands-on aspect. But as part of our mechanical metallurgy lab, we've integrated metalworking, and students have to design and fabricate a functional tool through blacksmithing. So there is a lot of form and function, visualizing what they want to make, and actually making a functional object by forging. You can see some of the principles here students will learn. They've got to both visualize, but along with those metalworking principles, we have there are a lot of principles that involve sort of color, temperature, understanding how the metal heat treatment works, understanding what the resulting mechanical properties are after heat treating and forging. So we're, just very excited there. The students were very excited. The outcomes, you can see one of the projects there, a student made a pickaxe there. So that's one of the activities that's already integrated into our mechanical metallurgy class. In our physical metallurgy lab, we've started to incorporate more and more metal casting, and actually worked with local artists like Grant Standard and James Van Nuys. They've done a lot of the sculptures downtown, and other artists on projects that involve things like lost wax casting. So you can see here some of the development there. So students learn about visualization, sculpting different forms, or maybe even 3D printing those different forms, and creating patterns to cast. So you can see actually one of the casts there was for that buffalo that's shown there in the right. That was created by one of our students a few years ago, and actually sold as a fundraiser for scholarships. And so, these are just some of those activities that really we've started to integrate into the curriculum. And based on a lot of the work we had done with metals in the past. And now I'm going to kind of turn it over to Dr. Donovan, and she's going to talk about what we're integrating right now in a lot of our courses.
So, we have a team here with Professor Whitehead and many people, but we also have gotten feedback within our own MET department. And one of the things that came back is the challenges students have with sketching, and sketching might not be something we think about in engineering, but really sketching is a great way to convey an idea or how you see something happening in a plant or concept. So being able to sketch can be a very powerful tool. But what we see is when students start hitting, like sophomore level, and we need them to draw crystal structures to understand what happens when we apply forces to them, it's quite a challenge to understand how these crystals are moving if you can't even envision a cube. So that's really the focus of this, was just getting students to understand how to draw cubes, and not just cubes, there's other systems, but starting with cubes because they're simplest. And so Professor Whitehead came into our introduction to metallurgical engineering. So it's the first year class, and he taught a module on sketching and just the importance of it. And we kind of left it open to the students. They could, draw whatever they want. So some of the students, as you can see on the bottom, have gotten pretty good at drawing cubes and understanding how those lines and depth work. On the upper right-hand side, our student, Kristen, definitely took that to a whole nother scale. She did quite well with that, but it'll be interesting to see coming into this fall, because I teach the sophomore level, and having a good understanding of how those crystals, well, not crystals, cubes, I guess in this case, which we'll talk about as crystals, how they're drawn will really help see how that sketching has helped our students. Also, it'll help in terms of design and 3D perspective as well. Another thing that I integrated into the 110 class, it was 3D printing, which gives you a lot of different steps. As you can see in the bottom, you have to have a concept or an idea, and you can see that sketched out. We have to put it into CAD, so some sort of computer aided drafting, and from that you put it into another software, which is a slicing software. And essentially, if you can think of a book with pages, that's what the slicing software does, is it takes the 3D object and cuts it into many slices or pages, with this analogy, and then you can print it. The cool thing about this for the students is they really get, this is kind of like a gentle introduction to what is design, right? We've got 4 steps here. What happens if we have trouble at the printer? Do we need to go back to the slicing stage, the CAD stage? So really kind of taking what we learned in sketching and applying that to a design project, very gentle design project. Then the upper right-hand side, this was kind of a fun one. One of our first year students did is they looked, I told them, look at home and see how 3D printing can help you in everyday life. So this student, his phone kept falling off his bed and cracking, and his parents were not pleased with him. So what he did was he had designed a holder for his phone in the dorm room. So there's that. The cool thing is it definitely had very real life application, but still getting a lot of these concepts that we see in engineering, drafting, design process. One of the new curricular activities we added with this as well, this is going into our sophomore level lab class, and this is precious metals. So this is bronze, but there's also been some stuff done with silver and gold and copper as well, but we're sticking with bronze for this, but it's integrated into our materials lab at the sophomore level. And in the upper right hand side, you can see an SEM of what this clay looks like. It's a bronze metal clay. And then you can see before firing on the left hand side, then after it's been fired, or sintered is probably the better word, you can see all those black spots or pores. And then you can see just kind of how that microstructure looks. On the bottom right hand side is just what it looks like before we put it into the furnace to fire it. So you can see a lot of the students' design there. And then bottom left, you can just see the before we put it in the furnace and after. But with this, the students learn about sculpting, sintering. We also talk about nanomaterials in this. The other interesting thing is, we're materials and metallurgical engineering. So thinking about how things feel, different materials. A metal clay feels quite different than a ceramic clay, like sculpting clay that students have probably encountered somewhere in their K through 12 education. So it moves a little bit differently, behaves a little differently. We also have, different firing or sintering in this case for this specific system. So learning kind of all those stages once again. This is another co-curricular activity. This was actually introduced in an REU setting, and actually, sure enough, we're teaching a ceramic engineering camp this week. It's called Glass Science and Pottery. And the students right now are actually down in the foundry with Professor Whitehead, and they're working on stained glass. So stained glass, you get to talk through a lot of different things, because we have a glass, which is a ceramic material, but as you can see with this, we have metals as well. And how do we get all these things to stick together? So you're talking about things like solder, fluxing, glass properties. The other thing is we have clear or transparent glass. We also have colored glass. When we start talking color theory, we're going to start talking about transition metals and those types of things. This is also another design component. If you can see on the bottom right hand side, Claire, she's got a bunch of different colors, but it's all drawn out, sketched out to be put together. So really unique one. And I'll actually talk a little bit more about this one later and some of the applications that are happening on campus with this. Another co-curricular activity we're bringing to campus is we are beginning to get a setup for a glass to do torch work with glass, but at this point, we're getting a furnace and a kiln. We're still getting that facility up, but currently we also have glass torch working, and you can see the images on the right-hand side were actually made by one of the STEAM officers, Jenna Saylor. You've probably seen pictures of her through here, but she helped lead our first year students through a glass pendant making. And with glass pendants, there's quite a bit of things you got to think about. Even though we're still working with a glass in terms of a transparent material, we also have colored glass. And with colored glass, we're once again to get the color, we need those metals in there. And so when you start having different colors, as you can see in the bottom left-hand image, when you start getting those different colors, they're going to be different metals. You're going to have to start thinking about things like thermal stress due to the coefficient of thermal expansion. You got to think about how the glass is moving at these higher temperatures. We also want to talk about vitrification and just visualization too. If you get to the end and your piece doesn't look pretty, there's that aesthetic component as well. But this was a module we integrated into 110, our introduction to metallurgical engineering. And actually the students our camp students right now are down at the foundry doing torch work as well. So we've talked a little bit about some of the activities we've been doing. Some of them we're building on, others they've kind of been introduced, but one of the big thing I really wanted to talk about was the two classes that for this grant that we really focused on. The first one was MET 110, which is that introduction to metallurgical engineering, and then our junior design course, which was MET 352. So kind of the goal for our first year students is they want, it's part social, just to be honest. First year engineering program, we've got students coming in from high school. It's kind of an awesome opportunity to explore their field of interest. And it's not just metallurgical engineering, this is a campus-wide program. My focus with this grant was trying to make it more experiential learning. When you are walking into something and you see torches and flames and heat, that can be very intimidating. So I wanted to gently introduce the students to a lot of concepts like heat, quenching, all those things. So very experiential learning with this. Kind of a side note, one of the things that I really wanted to focus on as well is this past summer or past fall, excuse me, we'd kind of come out of that COVID year, and it was good talking to the students that I had during that first class, because this 110 class is really to build camaraderie and teamwork. And the students during that COVID year, I had them just because the rules split between two classes. So they had social groups within a Tuesday section and a Thursday section, but the groups never got to really interact in person. There was Zoom meetings, but a Zoom meeting with 20 plus students on there isn't a great way to build team working. So I really wanted to do a better job focusing on that for 110. So I made teams through a lot of the modules we did. And then for case study number 2, the junior design, Dr. Keller was really the big lead on this. He had started looking at what we have in the hills for minerals, and he did a great job doing a lot of the early on work of, can we even take what we have in the hills and make functional ceramic bodies with them? And so he really promoted that. The cool thing was with this one, just a little background on it, we literally handed the students the buckets you see on the left hand side at the bottom. We handed them buckets from the Black Hills and said, I should say we handed them buckets and chemical data saying what's in here. So they had the raw material and the chemistry to figure it out. And the cool thing is they really took it and ran with it. But it was Dr. Keller who really spearheaded that. The other thing too that I would really like to note is we also had 2 different companies that really they donated 2 of the buckets we saw. So we really had company engagement industry engagement even on this level, junior design level. So that was pretty fun. Dr. West is going to talk a little bit about the NSF assessment, because we have this program, and even though we're integrating it into the class, we need to assess the program as well. So,
well, yeah, we're going to team up a little bit on this, but we wanted to talk about some of the things that some of the outcomes that we want to have happen. The first thing that we have begun looking at is student self-efficacy. And, I think Dr. Donovan's going to actually present some of this data later. But, the idea is, are students gaining confidence in the technical environment, and do they feel confident in what they're working with? Maybe feel more confident about their understanding of different processing or materials fundamentals. We've also been looking a lot at what types of students are engaged by the program. And this Herman Brain Dominance Inventory, which is shown there on the right, talks about the different typologies that people have, so-called intellectual typologies. The upper left being what you think of as maybe the more traditional engineer, highly analytical. But we have a lot of data on campus that has been generated in looking at our students, and when they come in, they are really all over the spectrum here. And then we look at our graduating students, and they tend to be very much up in the upper left, the traditional sort of engineer is what you think of as an engineer, highly analytical. And really that data really suggests that what's happening is we lose a lot of those students in the engineering curriculum. A lot of those students that may be very creative or have different skill sets from normal engineers, they would make great engineers, and they have skill sets that people want. Maybe they're more intuitive or innovative. And so, one of our hopes is with this program, can we really engage and retain more of those students that may not be sort of the traditional engineers. And companies, want those students. And so, we've also been looking at some other different instruments in terms of trying to quantify creativity and critical thinking. And Dr. Donovan's going to talk a little bit about some of those, results.
Thanks, Dr. West. So kind of diving into our first case study with kind of some of that assessment in mind. As I said, this is the MET 110 course, so it's designed to help those first year students build a solid foundation. And by solid foundation, we mean both academically and socially. This is also an opportunity for new students in the department to take a common course. So all those first year students that are going to be metallurgical engineering, they take this course together. So a great opportunity to meet with their peers. And the way this is taught is it's a lot of traditional metalworking lab skills. So things like welding, blacksmithing, casting, glassworking, a lot of those. So usually it's a lecture on the lab and the science behind the lab. And then we go and do the lab. The really awesome thing about this particular lab or module series that I did was I couldn't do it alone. I had 20 students, and having 20 students trying to blacksmith at once is really hard. And I'm fortunate, or we're fortunate, that we have some strong student groups. So I had reached out to the casting club, the welding club, steam club, and all these different organizations. And I said, hey, I need help with this. And it became, they all were great. They all jumped in and pitched. In the top picture on the left-hand side, you can see SD Medberry and Chris Mercado, the first two on the left. Chris, you probably recognize, he was in blacksmithing club and he's in a couple of them, but he's a sophomore at this point. He was a sophomore level student interacting with our first year students. SD was a graduating senior at that point, interacting with them. So they got a lot of peer-to-peer mentoring, which was really good. And also, with labs, if you remember, there's some of the downtime, and this was a really good opportunity during that downtime for students to have conversations with one another. In the bottom right-hand side, you can see students doing some tensile testing. We have Madeline Fiesenmeyer there, and then the other female is Cassidy Chauvel, and they both were really great in leading this. So it was kind of a rotating lab thing, but once again, they got that peer-to-peer mentoring. Madeline actually at this point was a graduate student. She was really great because she also helped with other things like career development and career resume building, but it was really good for the students to see just different student leaders, within the department. So Cassidy had actually spent an internship at Nucor, and she had spent a great amount of time during her internship doing mechanical testing. So she was very familiar with tensile testing. We also have impact testing. She did a lot of that. So it was really awesome for the students to see, Cassidy, who during this time was a junior, teaching this module. So it was also good for our upper level students as well. But it was a really positive experience, I think, for both our upper level students, and also a great way for the clubs to recruit and retain students as well. Just kind of a quick, wrap up of this case study. So some of the self-efficacy, those are questions that are phrased like, I feel like I am a creative individual. Those are the types of questions you'd ask. These particular questions here are based more around fear or stress or anxiety, because you walk into the foundry and people are blacksmithing. There's, flames, fire, it's all safe, but there's also pounding of hammers. So it's a lot to take in at once. So I wanted to make sure our incoming students became comfortable in those types of settings. So the questions you see, or the results you see here, were based on questions like, if asked to do a metal casting, how would you rate your emotional response? So that would be like very stressed to very excited, and you can see this range. For the metal casting, you can see before doing it, they would have been very stressed and somewhat stressed. We see some of those responses, but this is a metallurgical engineering program, so you can see actually quite a few students were excited to do that. That's something they look forward to, but you can see there was a shift from that somewhat stressed early on to a little bit more positive. The big one, though, was the glass pendant. So that was a different material, different medium for them, and we saw a pretty significant shift. As you can see, the yellow bars on the right-hand side were for the, if asked to do create a glass pendant, how would you respond? And you can see two yellow bars there. So there was a lot of students walking into that who were pretty anxious and stressed about working with open flame torches and gas tanks and all those, things that might be considered stressful or scary. And we can see a big shift with that after, taking the lab, that mindset shift. So that was a big thing I was excited to see. There's also another series of questions regarding creativity and metallurgical knowledge, similarly phrased. Big thing we saw is before and after. Before, they didn't necessarily think of themselves as somebody with a ton of metallurgical knowledge, which is good. That's why we have a degree, right? But really, we saw a great shift, both in creativity, or innovation is another way to think about that, but both creativity and the metallurgical knowledge. After experiencing this, the students had increased confidence from that. Case study number 2 was that junior design. And just a quick reminder, we gave them those buckets of minerals from the hills and said, process it and give us a product. And so the cool thing coming out of this is design itself can be a very open-ended question, right? This isn't 2 + 2 = 4. This is more like 2 + 2 = what the customer wants, right? There's this iterative nature to it. So it's the very first time students are getting writing up a design project or idea and really having it handed back and like, we need to think about this again. So it's a challenging just in that way. The other thing was we didn't define what the students had to make for a product. We said, make a product. So the cool thing is they all came in with different perspectives. So one of the most complex ones in terms of geometry was probably the grubby. One of the groups had made a grubby, and you can see the stages of, you do a first fire, and you can see that on the left-hand side with the orange. You then glaze it, which is you put a glass coating on it to improve the properties, and then you get the final product. And that's what we see with these 3 here. So grubby was a very challenging one. They did an awesome job, and there's definitely learning phases, of challenges. At one point, grubby lost his legs, and we had to go back and figure that out. So, like I said, a lot of iteration. The teacup on the right-hand side, as design projects have it, this one kind of got pushed to the very end. We also had equipment come in the final hour, so it worked out well. But this team, due to the time constraints, they actually did what's called a single fire. And when you single fire something, you don't have this first fire, which you see on the left-hand side with grubby. You dry it out and you glaze it, and then you fire it, which is also, it can be challenging because your piece can explode in the kiln or your furnace, whatever you're using a fire. So being able to do this was quite challenging in itself, but they were able to do that. A couple of the other groups, we've got Dr. West on the left-hand side. This one was fun because they had multiple, technologies they used. They used a scanner, scanned Dr. West's head. They missed his glasses on this, but that's okay. They scanned his head, and then they had made a mold, and then they had cast it into that. The interesting thing that came out of this one is it was amazing what they'd done, but it also brought in an ethical question, which comes in if they have, access to Dr. West's head at this point. Like, what is okay to do with that? Is it okay to go mass produce Dr. West mugs? We said yes, but really it's an ethical question there, right? Just because we have this knowledge or access to this, what can we do with it? So it was kind of a good discussion around that. The next group, this is a very processing heavy one where they looked at 3 different versions of things, but they were a group that did shot glasses. And then they're like custom school mine shot glasses with the M's. So maybe there's opportunity to sell some of these things. And then the group on the right, they actually created a lot of glazes. And the cool thing is there's a lot of glass that's left over from just stained glass, some of the pendant makings, and it gets crushed and it can't be used. So the student actually took those and recycled them and made them into glass, which was pretty cool. That group had that. And I'm really showing the glazes, but they also had clay nesting bowls from those as well. Some of the big expected outcomes from this is we want to propose and establish a student art and engineering competition on campus. We kind of did that with our junior design. We did have a competition for both science and art, but a bigger competition on campus. And we also would like to develop a national competition for the ceramic materials design through ACERS. Actually, one of our students right now she was elected or nominated to be on the Presidential Student Council for ACERS. And so she'll be traveling to ACERS and presenting there this fall on actually some of the glass glaze you saw before. She'll be presenting on that, but also being a part of that. We're hoping she'll be able to help us with, making a national competition. Also, a lot of this work was also published at ASEE, which is the American Society for Engineering Education. One other quick comment: on the upper right-hand side, there is a metalworking challenge. It's called the 150 millimeter challenge. It's really cool because we had that on campus, and a lot of the students got to see what you could do with just a small piece of metal. Some extended outcomes. I'm very excited to talk about this. We partnered with the Rapid City Arts Council to raise art and engineering awareness in the community. One of the super cool things I want to talk about is actually in the middle. There's a collaboration right now. Dr. Keller is spearheading this, and Professor Matthew Whitehead. He actually has worked a lot with stained glass. So working with campus, specifically the Newman Center, they're looking at doing a stained glass design, and Professor Whitehead will be leading that. They've got a design, they've bought the materials for that, so there'll be stained glass in the Newman Center on campus, which is pretty cool. You can see a picture of STEM outreach on the right-hand side, and then on the left-hand side, I actually went and attended, I shouldn't just say Professor Mitchell's also in this, and then Jenna Saylor as well. We went to the South Dakota High School STEM Education Conference, and a lot of high school teachers from South Dakota, middle and high school teachers from South Dakota come there. And so we brought metal clay there, and they had an opportunity to work with that. One of the cool things is we had some different groups actually come and visit campus just because of our outreach there. So it was pretty fun. The other thing I really wanted to spend time talking about was, we're talking about outreach in the community. This is a big thing we have coming up that we're pretty excited about. We are partnering with Elevate Rapid City, and we're going to do an art and engineering mixer. That will be on Thursday, September 15th at from 4:30 to 6:30 p.m. And that's at the David Lust Accelerator building. And that's right next to the library, or not the library, excuse me, the post office, if you guys have seen that. We'll have a keynote speaker, which is Professor Quinton Owens from Black Hills State, and he's been great for us to work with. There's pictures actually of his work on the right-hand side. He had worked with Tony Gerlach. We've talked about her earlier. He had created like ceramic molds and shapes for glassworking. A lot of it was topology, and you can see his printer, his ceramic printer in the upper right-hand side there. But his focus will really be talking about that crossroads of art and technology, which he does a really good job on. But this is a mixer I'm hoping to promote. Another cool curricular component that's coming out of this is we have a ceramic engineering miter. This is actually hot off the press. The South Dakota Board of Regents just announced this. Kind of the two big things that came from this, which was part of the grant, was we have a new applied glass and ceramics engineering class, as well as the fundamentals of glass and ceramic engineering. The big push with the ceramic engineering, as you can see, it's very geological heavy as well. So a lot of the geological students will probably be interested in this, but really it's a mineral industry's push or motivation for this minor. And as I speak, the students are down, as I said, working with glass, and I don't have pictures of that, but some of the fun things they've done is somewhat like our junior design students, except we're making them work for their clay they're making. But we went out and did field trips, and they had to collect samples from around the Black Hills. We actually have a high school teacher that had been very interested. So he's also taking part in the camp. And then we have a community member as well who has been learning a lot about the science. But we've done everything from collecting field samples to the upper right-hand side. They're doing mineral processing. And then we also were able to do an industry tour as well. And so that's a couple of things we've been doing with the camp, but really we're rolling that out as part of this program. And this will be a quick video on art and engineering.
At South Dakota Mines, we use the science of metal and glass to empower works of art. Students work with both professional artists and STEM professors to infuse their creations with metallurgical and materials engineering, while projects are inspired by our industry partners to bring you to the cutting edge of science, engineering, and art. Come change the world with us. Check out this one-of-a-kind art and engineering program offered only at South Dakota Mines.
So that kind of wraps up the presentation. I do have a couple acknowledgements, a lot of it's from pictures you've seen, but just a little information about the grant at the top, the NSF agency. that had funded that. There's a link to our website. I'm still working on it. And then just a thank you to marketing and communications. And that's the end of our presentation.
Well, thank you, Dr. Donovan and Dr. West. We do have a few minutes for questions, about 8 minutes. So if you have a question, there's the Q&A box on the bottom. And we'd love to have a couple questions for our talented faculty here. A lot going on. I don't know when all of you sleep. You probably don't. All right, we have some questions. So Nicole Stingle gave, she was clapping. She had a little clapping thing down in the chat. So, all right, any questions? Some more kudos there.
Hey, Nicole, do you want to talk color sometime?
She may have left.
Oh, bummer. I'll email Nicole.
Well, while we're waiting maybe for a few questions, I just want to really acknowledge the work of Dr. Donovan and Dr. Keller in particular. This, we really think that this program has a lot of potential, both to increase our student retention and really create better students, more well-rounded students. But as you can see from some of the stuff that Dr. Donovan presented at the end, it really has a big potential to engage the community and young students and get them interested into engineering. Looks like there's a question there. And actually, I think maybe Dr. Donovan, you could talk about the interaction with mechanical on this grant.
That's a great point. We actually have Dr. Cassandra Birincott, I see on the attendee list as well. Dr. Birincott is a mechanical engineering faculty member as well. And so we're doing assessment in both programs. She can probably actually speak to this better than I can, but I do know there are some like Professor Whitehead goes, I believe, into Dr. Lally's class and probably Dr. Landy's class as well over there. So there's some of those components integrated there as well, but she would be able to speak to that, sorry, a little bit more. There is, I would say, some crossover, but right now, to some extent, Emmy's kind of the control and we're doing the knobs. There's opportunities for more campus engagement, I'd say, if there's a next level of funding. That was Dr. Birincott, does that about cover it, or? I don't actually know, I guess, if the attendees
May not be able to come on.
Yeah. But I guess I would say Dr. Birincott's definitely running a point on the ME side of things, Eric.
Well, yeah, and I think a lot of those activities that Dr. Donovan described, like the visualization and things like that, Dr. Whitehead is bringing into those ME classes.
And it looks like Dr. Birincott answered with, she can't unmute, but yes, we have components integrated into ME, but following the first round of work in Metallurgical, we hope to integrate more of these activities. So.
And then one question that I see is the mixer open to alumni?
Absolutely. That's why we're giving it a shout out. If this speaks to you, we would highly encourage you to come to Elevate. We're looking to engage on a community level. I mean, we're starting to, but we really are looking forward to getting feedback from the community. And frankly, I said one of the community members in the ceramic, they had heard about this class we're doing, and they are an artist by training, but they were really excited to learn about the science behind ceramics and glasses. So we've had an artistic member of the community coming in, and that's really what we would like to see. So we'd love it if the community would, if you're interested, we'd love for community and alumni to come.
And then a question about, is there a glass blowing lab on campus?
We have, oh, sorry, go ahead, Dr. West.
Oh, no, I was just going to say, it is almost complete. We're actually, we have designated part of the foundry as the glass blowing lab. So that space is all sort of cleared out. All the infrastructure is there, ventilation, power, gas. What we're actually waiting on is just some more of the major equipment. During this pandemic time, there's just been incredible lead time on some of this equipment, but we're very, very close. We're actually waiting on a furnace, a new furnace. We've got what's called a glory hole. If you've ever seen glass blowing, that's where you kind of work the metal. We've got a big annealing furnace and some other things, but yeah, we're actually very close. And we're really looking forward to that because Tony Gerlach, which we mentioned, this glassblowing artist, she's really eager to come down and actually start working with the faculty and students. And so no, that's really interesting. And I noticed that there was another comment maybe before we quit. Someone said, I'd like to commission some art from engineering students, but it's very interesting that you mentioned that because we think that actually has a lot of potential, this sort of entrepreneurial aspect of some of this, creative activities. So we've actually been in talks with the bookstore about, creating different, art that might be attractive to alumni or other people. And so, yeah, it's interesting that you mentioned that because you may be able to buy some of their art from the bookstore soon.
There's a question about, does chemistry still teach technical glass blowing?
No, they don't. There are a couple of departments that are interested in getting that glass blowing lab back up. No, they stopped teaching that, I guess, quite a few years ago. But now that we have this capability back on campus, we're actually hoping that we can, engage with more departments and curriculum with this capability.
And kind of along those lines, one of the cool things Jenna Saylor did, she's leading the torch working right now. There was a student that had broke what's called a glass viscometer, and you put chemicals through it and you can measure viscosity. And it snapped in a point where the only problem was it was leaking air, and it was pretty impressive because people were like, just super glue it. And the chemicals you're putting in this would eat through the super glue. You can only fix it with glass. And so it was pretty cool to actually see her take a $300 glass viscometer down to Foundry and just quickly, fix it where it's completely functional now, just because she had the skills to do that. So instead of wasting a $300-400 viscometer, we've got it fixed and up and going again. So that was kind of a cool thing, I guess. I also saw a question.
Go ahead.
Oh, I thought I saw a question from Tim. Yep. We are engaging with local artists, and that was kind of the nice, you'd asked, are you engaging with local artists in these specialties, glassworks, ceramics, and metal sculptures? I would say yes, having 2 artists on the grant has been nice because they really have a connection with that community. So we are, I would say, engaging and would like to continue to do so. And hopefully with the mixer, we'll begin to meet a lot more, at least for me, I'll be able to meet a lot more of those individuals in the community.
Just going to say, I think that was the last question that I see. All right, we're about at the top of the hour. So again, thank you, Dr. Donovan, Dr. West, and thanks to everyone being on today. We did record this, so if you want to watch it again or share it with someone else, it'll be on our YouTube channel here within a day or so. I did put a survey link into the chat as well. We'd love to hear from you. And then August 18th will be our next Lunch and Learn. It will be with our athletic department as we head into the fall. You'll get a preview of the fall athletic season here at South Dakota Mines. And then we have a fun event downtown Rapid City on the 25th of August. It's Hard Rock Night at Summer Nights, which is our big community event here in Rapid. And we'll have some of our teams down there, and some of our camp teams will be down there as well. And hopefully a lot of alumni and friends come out for that. So that's downtown Rapid City on the 25th. And then you can see our other events on our Facebook page or our website. So again, thanks to our presenters today. we'll let them get back to camp that's going on. And thanks all of you for joining us and your interest, continued interest in South Dakota mines and great things that are happening here. So everyone have a great rest of your day. And thanks again. Take
Thank
care.
you.
Thank you.